This video will show how to use the fast matching algorithm to automatically trace neurites from light microscopy image stacks. For this demonstration, I have loaded an image stack without any image processing operations performed on it. I will also open up the Z projection of the stack. Inspection of the Z projection will allow me to estimate some parameters which will be used by the fast matching algorithm. I will zoom in a little bit on the Z projection. Here I see that the radius of the branches is about 2 to 3 voxels. On scrolling through the image, I also see that some of these branches are quite short. I would like these short branches to be traced, and they have a length of about 15 voxels. We are now ready to start the automated tracing process. Click on the Automated Tracing tab and then on the Get Initial Trace button. Choose Fast Matching from the options listed. This algorithm requires an initial set of seed points to lie on the structures that we want to be traced. Seed points can be generated automatically by specifying some parameters within the fast matching dialog box. The mesh defines the minimum separation between the seed points that will be placed automatically. The threshold value is the minimum local intensity that the seed points are allowed to have. This threshold should be set to a value higher than the background intensity in the image. The minimum radius, step size, and maximum radius are parameters that are used by the multi-scale LOG filter that will be used to find the seed points. These values should approximately match the radius of the structure that we want to be traced. Guided by the radius I estimated from the Z projection, I will set the minimum value to 2, the step size to 1, and the maximum radius to 4. I will now proceed to generate seed points automatically. Seed points can also be placed and edited manually. To do so, right-click within the image window and choose the relevant option. Once the seed points are obtained, we can set the parameters for the tracing algorithm. The max dist parameter is the distance that the traveling front is allowed to propagate in a single step. Choose this value to be larger than the width of the structures in the image, but smaller than the length of the smallest branches that you would like to be traced. Knowing that the radius of the structures is roughly 2 to 3 voxels, and the short branches I would like to be traced are about 15 voxels long, I will set this parameter to 10. Number of steps is the number of increments to the trace that can take place using the algorithm. You may set this to a low value and increase it later, or choose a high value and let the algorithm decide when tracing is complete based on the contrast value of the last added branch. If the seed points are appropriately placed, the algorithm will trace the bright regions first, followed by progressively dim regions. The contrast values should be enough to separate the local foreground from the local background. I will set this value to be 0.05 for this case. The last parameter we need to set is anisotropy. Light microscopy images typically have a different Z resolution compared to its resolution in X and Y directions. I know that the resolution in the Z direction is about a third of its resolution in X and Y for this particular image. Hence I will set this value to 1 in X, 1 in Y, and 0.3 in Z. We are now ready to trace the neurites in this image stack. Once we run the algorithm, the console log displays the step number and the contrast value for the trace increment in that step. The algorithm can be paused midway for the trace to be inspected and saved in its current form by forcing the algorithm to quit at that stage. I will allow the algorithm to continue and suggest an appropriate place to stop based on the contrast value I had provided. On completing fast marching, the trace that was obtained is further optimized to better match the underlying intensity. The initial trace generated in this manner may contain some incorrectly merged branches. Such errors can be corrected automatically using the online learning module of the software. That module is the subject of another demo. The initial trace obtained from fast marching can be saved for later use using the Save Library option. That is all for now. Thank you for watching.